Everyone, welcome out to the next video of my SQL Fundamentals video series. If this is the first video in the series that you're finding, no worries. Every video can be watched independently and 100% by itself, but if you would like to see those other videos in the series, go ahead and find those links in the description below, or I'll also put a link to the most recent video before this here on the screen. And if this is the first video that you're seeing in the series, then let me just explain the tech stack that we're using for these tutorials. I do have an AWS RDS MySQL database instance hosted in my AWS cloud. And then what you see in front of you here is a desktop database editor called dbeaver, if you're not familiar with it. And I have this desktop database editor connected to my AWS RDS database. And so any data that I'm manipulating here through this editor is going to be applied to that database up in the cloud. And so they're connected. And so whenever I insert data and then query it, we're querying directly to that database. And whenever I delete something or update it, then again, that's being applied to that database. So you can do the setup locally. So instead of pointing to a database up in the cloud, for example, you can point to a local instance of a MySQL database or any database for that matter that you want to work with. But that is the setup that I have running right now, just so you know. All right, everyone, let's go ahead and get started. In the last video, we talked about using the order by clause to order our results set. And in that video, I mentioned the next video in the series, which is this video you're watching here, would be about the order of execution in SQL. But I decided not to make a video on that just because some of the pitfalls that you would find from the original SQL language are no longer an issue when it comes to the order of execution, because many of these engines have added extensions to their engine logic. And those extensions have kind of done away with some of the pitfalls of, for example, using aliases in the group by or the having clause. And so you won't run into some of those issues as much. And I just thought, because of the disparity between the extensions in every different engine, and for the most part, a lot of those engines having extensions, that we wouldn't need to cover the order by clause, or at least it wouldn't be as big of a bang for the buck. And so with that, I've decided to move on to the next topic, which is joins, and that's what we're going to be talking about here in this video. So let's go ahead and get started reviewing what we're going to talk about here today. And I have a few bullet points here. We're going to be talking about what is a join. If you don't know what that is, just stay tuned. I'll get to that shortly. Very important in SQL. We'll be talking about the different joins available to us in most engines. So that's going to be the left join, the right join, the inner join, also aliased as just join. The full outer join, again, also aliased as the keyword full join. We have a cross join, or what's known as a Cartesian join, and then we have a self join. And then finally at the end, I'm going to take our dog boarding facility ER diagram, and we're going to join a few of those tables together so you can see what it looks like to join on multiple tables. All right, and then with that, let's go ahead and get started on talking about what are joins. And with that, guys, I just want to go ahead and switch us over to dbeaver here, where I'm briefly going to just show you the tables we're going to be using in this tutorial. New tables in this series are the categories right here and the products left table. These are simple tables I've set up. They have very little constraints, a low amount of columns. These are just to drive home some of the ideas on the joins that we're going to be talking about in this tutorial. And then towards the end of the video, I'll be using those two tables actually for the majority of this video, but towards the end, we'll be bringing back in the dog boarding facility tables and showing you how to join on foreign keys and how to join on multiple tables. And all these tables have data within them. If you're interested in learning how to create or insert data in the tables, please find links to those videos in the description below. With that, let's move on to what the syntax of a join looks like. This is what a basic join looks like. Here I'm doing a left join, which will be the first one we talk about here in the list of different types of joins. Generally, the syntax is a select statement with what's called the left table. You're going to hear tables when you're talking about joining in SQL. You're going to hear left and right, and it's a good way to think about it. Two tables, one on the left, one on the right, and then sticking those together or joining those together horizontally. And I'm going to show you an example of that here shortly. But this is the table on the left, products on the left, categories on the right. we're using a join keyword. This could be left join, right join, inner join, outer join, etc. So you could switch this up. And then this is your join condition. When you use the on keyword here, that's defining how you're going to join these two tables. What is going to be the glue that's going to stick these things together, okay? So let's execute this real quick so you can see the result set. And then let me pull up the two tables here that make up the statement. Okay, so what is a join? A join is us taking generally related data, I have products here and I have category information here. Together, these two make sense. They enhance the result set. You're not really going to see joins in the wild that are totally different or unrelated data because it wouldn't really enhance the viewer's understanding of the data further. And so it wouldn't really make sense. You could do it, but it's not something you're going to see. Generally, what you're going to see is you're going to see related data being joined together to give you a bigger result set and give you more information. Okay. And so you can join tables vertically. This is called a union, and they have to be the same columns. And there's a few things that need to line up. We're not talking about that right now, but you can also join tables or information horizontally, and that's what joins do. They take the table here on the left, and they take the table on the right, and they smash them together, and they return you a new table or a new result set that have the data from both sides of the information or both sides of the table, the join. And so as you can see here, I have 4 columns and 8 records in this left table. And then I have 3 columns and 8 records on this right table. And what I get from running the statement is combining those. So I now have 7 columns and 8 records. And we see that the first 4 are the columns from the left and the last 3 are the columns from the right. And that's exactly what happens. It literally just, boom, sticks these together. And that's what your column and your records look like. Now, whether it's a left join or inner join, the nulls and things like that and how they line up are going to be different. We'll get into some of those details here. And just to call out the join condition here, we're pretty much saying, hey, take these two tables, left and right, take the category name column from the left table and join it to records on the right table that have the same value in the column name. Okay, so we call out the two columns. You say, okay, for this first example, let's get the value from the category name, which is fruits, and let's go over here to the right table and see if there's uh, any values in the name column that are equal. And we do find that. And so what happens is now you see we get these two stuck together. When it doesn't find them, depending on the join condition, it may give you a null. Again, we'll get into these details, but for example, we were not able we're not able to find a pets here. So if you look at pets, right, we find it right here. We came over to the right table. We said, oh, look at the name category. Find me a value of pets to line up with the category name value of pets here. And there isn't one. So what happens is on our left join, and we'll get into the details, you get a null value here. But outside of that, this is generally how a join works. And what's important is these on keyword and the join condition, they have to be of the same data types. Okay. So this is a string and this is a string. And so we're able to join them together. If this was an integer and this was a string, that would not work. And now there's some implicit casting where if this was a string of 1, 2, 3, and this was actually an integer value of 1, 2, 3, then depending on your SQL engine, they will likely implicitly convert this string to an integer or vice versa to join these two records. But that only works in certain cases where the SQL engine is able to derive or able to cast or change the data type. Having the word fruits in the number 1, 2, 3 here, it wouldn't be able to do that. And then you also can go take a step further and control that behavior by doing an explicit casting where, this was a string of 1, 2, 3, and this was a value of 1, 2, 3. I can explicitly cast this string to an integer, and now they'll be of the exact same data type. And I don't need to rely on the SQL engine's implicit casting of those data types, because sometimes it won't cast things the way you think it will, and that could mess up your join clause, and that could potentially be an issue you don't find for a while. And we don't want to do that. So generally, I just want to let you guys know about this. When you're joining, you need the same data types, and if they're not the same data types but they're close, like a string and a number, for example, you can explicitly cast one or the other so that those line up and the join makes sense. Okay, so that's kind of joins as an overview in a nutshell. Let's go ahead and move on to a left join here. And actually, one thing that I just reminded myself of is that you also don't have to use foreign keys. Okay, so that's something you'll see. A lot of databases will set up foreign keys, and the whole point of foreign keys is to create these constraints between the different tables because they know there's going to be joins on them, right? And so when you create a foreign key, you're pretty much telling that table, hey, if you put any new information in here, it has to be of this data type because it's related to another table. And that means that in the other table, because it knows about that foreign key, the same thing happens. And so that way, when you go to join against those foreign keys, the joins work out naturally and there's no issues because they're of the same data types. And you don't need to have that, but obviously there's a lot more chances for errors when joining when the data types don't match. And that's why we do use foreign keys so that we can add those constraints or those safety nets there to make sure that we don't create bad data types in our tables that we know we're going to want to join against. All right, guys, moving on to the left join example here. We've already seen this in action. From the syntax, this is the part that's going to change depending on the join that you're using, and the condition you're using may change as well. But if this was a right join, it would say right join. If it was an inner join, it would say inner join. But here on the left join, it's going to say left join, and that's telling the SQL engine how we're going to join these two tables. And what a left join is, well, first of all, it's the most common join you're going to see. So I'd probably say, rough estimate, 80% of the joins that you're going to use on a daily basis are going to be the left join. Usually because what you're trying to do is you're trying to enhance the information on this left table. So we have this left table here. We're saying, it's not enough information. I want more. But generally, you want all the records from the left table. And that's why I think it's used so prevalently, is that most people are kind of thinking in that fashion of building their result set in an expanding fashion. And so usually you want to start off with your minimal amount of data that you're concerned with, and then add data on top of that. Okay. What a left join does is it will take every single record in your left table. So if you had 10,000 records, we would get 10,000 records here. And it will look to the right table on the join condition. So looking at these two columns, and it'll say, hey, do I have a value that matches this value in the left? So is there a one in the right under the name category? So we do have a fruits value in the name column that matches the fruits value in the category column. Perfect. So let's join those together. And it'll do that down the line until it reaches a point where it can't find a value on the right. And what it'll do there, this is something that happens in left joins, is it will still return columns for that, but it will give you null values. Okay. So if it can't find the matching value for the condition, it will just give you null values. I explained that already, but I'm just going into more detail here. And that's essentially what a left join does. It's a way of getting all the information on the left. You don't want to lose any of that, and getting whatever extra information you can from the right. And then you can filter out these values that have nulls and things like that if you want, but there's other join conditions that will do that as well. So that's a left join essentially, and that's what that is going to look like. Now, kind of the brother to the left join is the right join, and we're taking those same concepts, but we're just going to put them in reverse. So I've essentially just done the same thing, but I've just updated the left join clause here to a right join. We're using the right join keyword. Let's execute that. Let's see the difference. Okay, so now we got the opposite. We've taken every record from the right table and joined it to the left, where the name category or value matches the value in the category name. Okay. And what happened is that this had extra values, just like we saw with the pets example in the last one. This had paper and process, but there was no products on the left table that had those categories, and therefore it shows us nulls. You don't really use this as often, but there are cases where you will. And it's really easy because it's just the opposite of the left join. It's just the right table takes precedence. We want to have all the information from the right table and whatever extra information we can get on the left table. All right, the next join we want to talk about is the inner join. I'm just going to put that up here on the screen and we're going to execute that. Again, we see, I haven't executed yet, but we see the same setup, right? It's just that the keyword has changed from a left join or a right join to now an inner join. Let's execute this and look at what happens. Okay, so all of our null values went away, which is a good thing to note. The inner join, what it does is instead of how the left and the right join act, the inner join looks at the left table and at the right table and their conditions, the category name and the name, and it will only return values where there's matches on both tables. Okay, so that's why all the nulls went away, because the cases where there were not matches on one side of the table or the other, those were being shown with the left and right join, but they're no longer being returned with the inner join. And that's essentially the difference and where you're going to use inner join. Also, a very popular join where people don't want nulls and they only want to see the enhanced information that has data on both sides. Okay, and that's what you get. Very clean and concise, straightforward, easy to understand. This is the inner join, and then as I mentioned, there's an alias for this, right? So the join keyword is synonymous with the inner join. Okay, so you can either write inner join or you can just write join and it's going to do the exact same thing. Let's execute this and you'll see you get the same exact result set. So don't get confused by that. You'll see join a lot in the wild. It just means inner join. And once you know that, then you'll know exactly what you're going to get back from that result set or what your expectations can be on that. All right, guys, the next join we're going to talk about is the full outer join or outer join. I'm just going to show you the syntax for that here and talk about what it does. Okay, so like the left join and the right join were brothers or twins, inverse twins, however you want to say that. The outer join and the inner join are also kind of inverse twins. And so the inner join would only return records that had matches on both sides. What the outer join does is it will return records on both sides no matter what. Okay, so essentially you're going to get every record from the left and every record from the right, whether they have corresponding values in the join condition or not. Okay. Now, one thing, I'm using MySQL, and MySQL doesn't support full outer join. Okay, so I can't actually show you this execution here. If you're in a different database engine that supports full outer joins, then you would be able to see what happens there. And so instead, there's a workaround in MySQL to mimic this functionality, and I want to run it for you so you can see what the results of an outer join would look like in a different database engine. Okay, and so what we're doing here to mimic that is we're taking a left join, unioning that. So what we're doing is we're taking two tables and horizontally combining them, and then we're taking a right join, again, horizontally combining them. Again, the left will have all the values on the left. Our left join will give you all values on the left table with, values on the right, but also nulls on the right from the right table. And the right join will do the opposite. And then what you can do is union these together and you get the output of what a full outer join would look like in other database engines. So let's just run this real quick and let's show you what that looks like. Okay. So, we did the left join here. We got all of our records from the 8 left. And then, we went to the right and said, give us all the records on the right plus any nulls. And then we did the same thing here on the right. And we stacked those result sets together. And so again, you can see that even though the left didn't have a match for pets, it's still shown, right? And even though these two values on the left, let's just look at that real quick. Um, so I can show you what the left table looks like. Select from products left. Okay. We're just going to do this in another tab. Great. So this is what the left looks like. You can see it had pets, null, and null. And then if we go back here and we look at our mock outer join, we can see we had pets, null, and null. So we get all those records, and then we get the other records from the right that didn't have any matches on the left because, again, the left didn't have paper process or the null that was contained in the right. And let me just go ahead and show you guys the right table as well. So select star from categories right. Let's go ahead and execute this as a new tab also. Okay, paper process and null. When you look at the results set, you see paper process and null here. Okay, so just want to drive home the point that if you were able to do an outer join or even mock it here in MySQL, you will get, whoops, you will get every record from both the left table and the right table. If there are values on both, they'll combine together. If they're not, then they'll have this null kind of set on each side, depending on which side is missing or is not. Okay. Hopefully that makes sense. I don't want to take up too much time on that. Hopefully, you can rewatch this portion of the video to try to make ends of that if you didn't quite get it the first time. All right, guys, our next join is going to be the cross join. So let me just delete these here real quick and trade this out here. Okay. And this is what a cross join looks like. We have the join keyword here and we're telling it cross join, but there's no join condition, no on keyword. And the reason for that is because with a cross join, you're taking every single record from the left table and joining it to every single record on the right table. And you can imagine if you have a lot of records on the left and a lot of records on the right, you're going to get a very large result set. And that's something you need to keep in mind because if you're looking at two different tables with 10,000 records, for example, or 100,000 records, and you're doing a cross join against those, I mean, we're going to go orders of magnitude greater records in your results set. Okay. I've added this order by here just so we can get a prettier picture of what that looks like. Let's just execute this and let me show you what we are talking about. So, and let me actually just add another one here. So cr.id as well. And then let's execute that. Perfect. Okay. So what we're seeing here is taking, again, every record from the left table and then joining it with every record from the right. So we have, if you remember, our first table, products left had, well, products right also had 8. Both tables had 8 records in them. And so what we're doing is we're taking the first record from the left table and joining it with every single record on the right. Doesn't matter if there's a null or not, it's going to join to it. And we go to the second value. Let's just show you that real quick. Select star from products left. Okay, and then again, we're going to do that in another tab. Perfect. So we had 8 apples, corn, chicken, and you'll look over here and see, okay, we have apples, we have corn. Again, there it is, fruits, vegetables, all 8. Okay, chicken was the next one. Again, 8 records. We're going to join with the 8 from the right. And this happens all the way down the line until you get to the very last. And again, vice versa. If we were to change this ordering, if I were to put the CR order here in front of this and we execute this, then we can see the opposite happens, right? I mean, it's not the opposite, it's the same, it's just ordered differently. We take each record it was on the left went all the way through 8, and then those are joined with the record on the right, the first record, and then those are all joined with the second record and all joined with the third record. We don't need to get too much in the details. You're not going to use this too often, or at least I haven't used it very often, but I want you to know about it and understand that it results in a very large result set, and it includes records from both sides no matter the condition. And that's why there is no join condition, because it doesn't matter, because it's going to give you back everything, joined to everything. Okay, so hopefully that makes sense with the join there. And I'm just going to show you another example of how you can write that join. write like this. Um, let's go ahead and get rid of that. Whoops. CRID here. Okay. So the only difference here is a comma, right? There's no actual cross join keyword in SQL. This is kind of a bit of a shorter syntax that you can write for a cross join. I wouldn't recommend this. It's confusing. People who are maybe not familiar with SQL, they might not know what this means, and they may be unsure of what kind of join this is. Let me just execute this here for you, and we'll see. We kind of went back to that first example where we had, the apples, and then every single record from the right table, and then corn and every single record from the right table, et cetera, et cetera, et cetera. And we did that by using the comma. If I were to just change this to a cross join, we will get the same exact result set. You can see nothing changed. Okay, so just to let you guys know about that differentiation there and the different way of writing that. Another way to do a cross join is to do an inner join, or again, these can be synonymous, right? Just the word join, but let's just keep the inner join. I like to be explicit with my join keywords just so everybody knows what's going on. When you leave off the condition on an inner join, it also acts as a cross join. Okay. So just something for you to know, or if you see anything weird, you forgot to put the condition on and you got back all these records, well, it's acting like a cross join. Again, this was an inner join, but without a join condition. SQL doesn't know how to join the two tables together. And so it just says, all right, I'm giving you back combinations of everything. Um, and yeah, just something good to know. Again, I wouldn't use this in the wild because it's not very explicit. People will get confused. Hey, this is inner join. What's going on? They may not realize that there was no join condition in the statement, and they may be wondering why you're getting back everything versus just the matching records as a normal inner join would return. And then the opposite of that is using a cross join with a filter. Okay, so you do a cross join here, but you do a filter using a where clause across the two kind of join conditions that we used on the inner join, and it acts as an inner join. Okay, so these are, you wouldn't want to use this in the wild, probably. You might as well just use the inner join, but I just want to call this out so you understand the different variations you can see. Again, pause these videos, review different portions, compare them if you want. But this cross join without, um, or excuse me, this cross join with a where clause filtering on, the two columns that we had used on the inner join will also give you a result that looks like an inner join. Okay, let's do that right here. And you get back the same result. Now I use the join keyword here, but let me just show you the inner join and get back the same result. Okay, just wanted to prove to you guys that the cross join with the where clause is going to give you back inner join type of result set there. Okay. And just before we move on to our next join, I want to mention one thing about the cross join. Let me just put that up here. Actual one. Um, you often hear this referred to as a Cartesian join or a Cartesian product. And this is actually what the Cartesian product is the result set of a Cartesian join. And the word Cartesian is just a term used in mathematics. I think Cartesian was a mathematician. And a Cartesian product is essentially the combination of two data sets and every value from one set combined with every value from the other set and vice versa. And that's a Cartesian product. And that's essentially what I've explained to you, but I just want you to know and not get confused. If you hear the word Cartesian join or you hear the word Cartesian product, they're just talking about the results of a cross join, okay, which you have seen here. Again, probably, kicking a dead horse is that every record from the left has been combined with every record from the right, and every record from the right has been combined with every record of the left, and then you get a Cartesian product from those two data sets as your result set here. Okay, so just wanted to mention that before we move on to our next join, which is the self join. Okay, self joins are interesting because instead of joining two different tables together, we're going to join the same table together. So we're taking one table and then joining it back on itself in a self join. Obviously, as the name suggests, the word self in there. And how you write that is using this kind of cross join syntax. There's no join condition because obviously we're joining two tables together, products left and products left. And, obviously whatever's in the name column is going to be in the name column for the second table as well because they're exactly the same table. And so what I've done here is I've ordered those results so we can just get a better idea of what they look like. And then let me execute this. Essentially, what you get is you get a cross join of the table back on itself. And so you get a Cartesian product of the products left. And I don't ever use this, but where you would use it is if you wanted to do an introspection on your table, you wanted to compare different records with other records. If you had a very large table, that may be hard to do. And so you do a self join to compare, record one with record 500. And then, for whatever reason you're comparing those two or doing some introspection on them, that's what you would use a self join for. And another way to write this self join, kind of like we saw earlier, is again using the inner join, but without any conditions on it. And we know that kind of created a cross join in the earlier examples. And because a self join is essentially a cross join, but with the same tables, that's kind of what you get here. And of course, we can just use the join keyword. If we execute this, we're going to get the same exact results. So you can use the inner join on the same tables to get a self join as well, just like we use that kind of cross join syntax to get that self join. Yeah, and the result set's the same. So pretty much everything I said earlier about the last syntax was holds here for that one. But I just wanted to show you that you can also go with the inner join method without the join condition to get that same self join when looking at the same table. All right, guys, we are at the final part of this tutorial where we're going to be looking at joining with foreign keys and joining multiple tables together, not just two. And so we're going to use this ER diagram here that we've set up in the earlier parts of the series. And we're going to join some of these tables. Namely, we're going to join the owners with the dogs, with the feedings, and with the foods. And you're going to see what that looks like. And these are real use cases, right? So these are how tables will be set up in some of your databases, and the data will be segmented. And again, we talked about joins being these horizontal joining of tables so that we can get more enhanced result sets that help tell the picture of what's going on. If I were just look at owners, I only get information about the owners. Now, if I join that with dogs, I get information about the owner and its dogs. And if I join that with feedings and foods, I get more information, and you start to paint the whole picture of the data contained within your database. And so that's where joins are very powerful and important, and how you're going to use them a lot in real projects or at your job. Okay, so with that, let's go back to dbeaver and let's take a look at a simple setup here using our dog boarding facility example. So I'm going to use left joins for everything here. Again, left joins are most widely used. They're kind of easy to understand. And yeah, that's what we're going to be doing. So what I'm doing here is I'm selecting from the owners table and I'm left joining with the dogs table, and I'm joining on the IDs. Let's go back and look at that real quick just to show you the IDs. And so I'm taking the owner ID and I'm joining it with the foreign key I set up in the dogs table called owner underscore ID. And again, the foreign keys are important because we make sure the data types are the same and we understand that there's a relationship set up. And so the engine knows that, hey, if you want to create a new record here, there needs to be a record over here that belongs to it. And they need to have the same data type. Again, this is going to make our joins a lot more foolproof. And so that's why it's important you want to use these foreign keys so you can make sure that you have data integrity across these different tables. Enough with that. Let's go ahead and execute this. Perfect. So what do we see? We got the left table, which is owners, Okay, we got the first name of the owner, the ID, the phone number, and then we get all the information again because we're using the asterisk here and we have it named out specific columns. We are getting all the information from the dog table. Okay, but this tells you already because we're joining on the condition of the owner ID, we know that John Doe owns Buddy, the Boston Terrier, because the owner ID matches the ID of the owner. We also know that the ID here for John Doe has another dog, right? And so you can see, and that's a good thing to call out here is that when you do a left join, you're going to see if there's matching on the right. You're going to see repeats in the records. And so we have two records. That's kind of weird. Okay. Well, the reason is because we're joining on the right, and on the right has two dogs to the same owner. And so if we had three dogs, you would see three records with John Doe on the left here, and then the different records on the right for each one of those dogs. Okay. So good to see real life examples to see how some of this stuff plays out. So essentially, what we can tell from this is that Buddy and Belle are owned by John. Maria Lopez owns Fido. James owns Spot, and Sarah owns Jasmine. Okay. Now, if we wanted to get kind of more explicit information about these results, we don't want to see these IDs and stuff because that gets, that can, if you're joining multiple tables or it's just not really helpful information. To review, we can make this a little bit more viewer friendly by just explicitly calling out the columns we want to return. Same exact join, but just a nicer, cleaner set of data. And so again, we see the same thing. John is here twice with Buddy and Belle. We just don't have to see any of those IDs. So that's one way of doing that. And now, if we want to learn more information about these owners and their dogs, we can look at the feedings. When were the feeding times for each of these dogs? So let's go ahead and do that here. Execute that right now. Oops, let me paste this in here. And so yeah, so this is your first example of seeing multiple tables joined together. Okay, we have three tables being joined together. We have, the first table, which is the owner's table, the second table, which is the dog table. Okay, and here's the join condition, which we're familiar with. Now we're taking a third table, the feedings table. Let's go back and look at that. Okay, and so what we're going to do is we're going to say, hey, give us all the feedings for each dog, and we're going to join on the dog ID. Okay, so we know we have an ID here for the dog, and in this feedings table, we've set up a foreign key for that dog ID, and that's how we're going to stick these records together. Is we're going to say, hey, for every record in this dog's table, go to feedings, find me any matching dog ID values that match the value of the ID for the record in the dogs table. Okay. Now that sounds confusing. Hopefully you're getting these joins. If not, please pause and review the video. Let's execute this and see what we get. Okay. You can see every time we do a join, we're getting more and more information, right? Our table is starting to expand horizontally. That makes sense, right? First table was only a little bit of data. Second table gave us more data horizontally. Now we're adding a third table, and that's giving us even more information. We can see here, as you add more and more information, we get repeated left records, right? We had two when we did this join. Now we have four because each dog that John owns had, two feedings. And so it expands our list vertically, or our result set vertically with those same records. And you can see Maria, she only had one, but her dog has eaten four times since it's been here at the boarding facility. James, two, and Sarah only had one record originally because Sarah only owned one dog, and then that dog has only had one feeding. Okay, so just want to drive that stuff home. And again, we're using the foreign keys here to join there, right? And again, we can see kind of a different example here. I'm going to show you using this situation where we can get the columns. So let's go I'm going to paste this in. And what we're saying is, hey, give us that same subset of clean columns we had, but also give us all the feeding data. This is another way of getting all the data for one table, but not getting all the data for another. So just want to show you guys that you can use the alias dot asterisk to give you all the data from the feedings table, which will be all this right here, but only give you a subselect of some of the data from the first two tables. Let's go ahead and execute this and see what that looks like. And there we go. We shrunk down horizontally our result set because we kind of got those explicitly called out columns here for these other two tables, but still got all of the data for the feedings table. Okay. And we can, of course, take that a step farther by getting rid of the IDs from the feeding column and just focusing on kind of the human readable information. Okay. So instead of the F star, I've pretty much taken two columns. You know, I don't want these three IDs. I just want these two columns here. And let's go ahead and do that. Okay, perfect. So now we are getting a very concise result set that is telling me a story of the owners, their dogs, when they were fed, how much they were fed. Okay. You can start to see how joining this information together is kind of creating a better story and giving the user more information to understand what's happening in this database, right? And with that, let's go ahead and move on to joining another table. So if we look at our ER diagram again, we've almost completed the full path here. We've joined this to this and this to this. And now we want to left join the feedings or the foods to the feedings. Okay. And so this this is a little bit different. Again, if you were in the series and saw when we created these, this is the parent table to this child table. And so this food ID is the foreign key to the ID of the foods. And so what this is going to give us is allow us to figure out what food was fed to that dog, at what time it was fed to what dog, and for what owners those dogs belong to. Okay. Anyway, let's go ahead and get back to that. And I'm going to just, as usual, paste this in here so we don't have any typing errors. And you'll see the same thing. We kept those records from the last one here, but we've added the foods dot asterisk, which is going to give us all the records from that table. And you're going to see something here. All right, we got an error. Column name in field list is ambiguous. You're going to see this sometimes when you start to join a lot of tables together. And the reason being is because the foods table has a name column, but so does the dogs column or dogs table. So let's look at that on the ER diagram. We have a name column here and we have a name column here. And what happens in SQL is that when you just put the word name, it doesn't know which table it's supposed to pull the name from. And so it gives you an error saying, hey, this is ambiguous. You need to tell me exactly what table you want the name value from, because otherwise I don't know which one to give you. Okay. And that's exactly what's happening, or what it's telling us is, hey, this is ambiguous. I don't know which one you mean. And so how we get around that is that we explicitly tell the SQL engine what name or what table we're pulling the name from. And how we're going to do that is by calling that out. Okay. And so what we've done now is I've realized, okay, I can't just do an asterisk because of the name columns. And so what I've done is I've actually explicitly called out which column or which table we're pulling the values from. Now, when we execute this, we're going to get our result set. Okay. And we're going to get it both with the name column and the result set, but the engine now understands which is pulling from which. Okay. And again, this is that human readable form. We kind of painted the full picture of our result set and our data as far as the owners, the dogs, the time they were fed, and the foods. We didn't go over the stays. I didn't want to make this video too long, but you can do the same thing you did here, but with the stays and the pens to understand, what dogs are staying, who owns them, how long they've been staying, when they got here, when they're leaving, and what pens that they're staying in. Right, same thing we did with the food, but we'll just show this one example here. And again, now we've joined 4 tables, so you've seen how these joins can be used. The owner's table, the dogs table, the feedings tables, and the foods table, and the join conditions you use for each example. And you don't have to use left joins. You can use cross joins or right joins or full joins or inner joins. But just understand that at each step that you use one of those joins, you're going to get those kind of results that we've went over. And using a left join kind of repeatedly like this will kind of give you that all the information here on the left and then expanding it to the right. And because we've set up foreign keys, we're not going to get a lot of null values, if any at all, because we've added those foreign key constraints on each table. And so you can't really create records on the right tables without having records on the left. Otherwise, the database engine will yell at you and give you an error for doing that. Another thing you do here, I just want to talk about before we end, is that when you have two conflicting names like this, and we're going to get the name in both cases, you can alias these. Okay, so we can go ahead and do an alias as dog name, for example, and then also alias the food name as food brand. We call it name, whatever. And we execute this, and now you can see that these have switched to, again, a little bit more human readable, more easily discernible values for the columns. Okay, so you don't have to do that, but it's just something that you may want to do, is alias these kind of repeat column names. Yeah, I think for the most part, that's going to be all we're going to talk about in joins. This is going to cover, I don't know, 98% of what you're going to see in the wild. Again, things like self join and cross joins, you don't really use those that much. They're not overly helpful from your day to day SQL use, unless you're in a specific role or in a specific niche where you're maybe testing or you know trying to compare values in different tables. For the most part, you're going to use left joins and inner joins as a majority, and then you'll occasionally use right joins, and you'll use outer joins as well. And with that, guys, I'm going to go ahead and conclude this video here on SQL joins. I know that was a lot of information. Joins are pretty deep and they're very important. So I wanted to give you guys as many examples as I could without keeping you here for hours. SQL joins are very important. If you don't understand them, you're going to be pretty limited in your SQL abilities. Definitely any place that you work, they're going to pretty much need you to understand SQL joins if you're working with the database. So, make sure you go back and review this video if you didn't quite catch everything. My apologies if I was moving quickly, but I did want to get as much information to you guys as possible in as short as time as possible. If you've been following the series, you're very quickly moving from a beginner SQL user to a more advanced SQL user here with the joins. Okay, and understanding those. If you did find this video helpful, please go ahead and click the like button. That helps me here on the channel. And make sure you subscribe as well, because I pretty much put out a video per week on software engineering, and so that's going to help you keep your tools sharp for your software engineering career. I appreciate it, guys. I'll go ahead and leave some links here at the end of the video as well for you guys to check out other videos on my channel.